All right, in this video, I'm going to go over this introduction to conservation of momentum activity that you did on your iPad with the simulations. You should have completed the simulations at this point, and one of the things that you should have noticed is that in each trial, if we take the total momentum before and after the collision, so we add up the momentum of both objects, that total momentum doesn't change. One key point here is that the momentum has direction. So on this one here, the velocity was negative, so the momentum is negative. So when we add up the momentum, the signs really matter. So plus 15 minus 10 is plus 5. And you should notice for every single one of these, the total momentum before is equal to the total momentum after. And this doesn't matter the direction the carts are going, if they have different masses, if they stick, if they bounce, any of those things. So for the analysis questions, you should have this done as well, and I'm going to go through the answers. Number one is just reminding us that negative velocity means direction, and in our case, we're going to say that's to the left. And momentum means the direction points to the left as well, and the velocity points to the left. It's moving to the left. And you should notice that the total momentum is equal, that like we just went over. For number three, write an equation showing the total momentum before relates to the total momentum after. A couple different ways we can write this, and we'll see this on the next page even more. We could write it the momentum initial equals momentum final, or we could say, oh, if we take the final momentum minus the initial momentum, we're going to get 0 because they're always going to be the same. Or, and I think this is probably the best or the clearest way, is we can split them up. The momentum of object 1 initially, so P for momentum, A for object A, I for initial, plus the momentum of object 2, or object B initially. Add those two momentums up, and you're going to get the sum of the two objects' momenta after as well. And this is just kind of a check. Make sure that you're realizing the numbers stay the same. And the examples here. The way these examples walk you through it is we're setting up a general equation first with just variables. And then we plug in the values. Don't forget the directions. And then we can solve for our missing value. This example here is pretty straightforward because we don't have any masses and velocities. We're just giving you momentums. And the next one here, similar thing. One thing you have to watch out for is the negatives. So the negative values there make all the difference in the world. You will get a completely different answer here if you forget your negative signs. It's not just, oh, I'll just make my final answer negative or positive. You'll just get a completely different numerical answer. All right. Some students, what they like to do is they will make a chart for each problem. You can certainly do that. That's kind of similar to this and kind of keep track of everything. If that's something you'd like to do, you can certainly do that. All right. So that is the summary of our introduction to momentum simulation for looking at collisions.